Hello student, I am Dr. Priyank Purohit from the Positive Arena, and my concern is to start the mass spectroscopy. Mass spectroscopy is a type of spectroscopy which will deal with the molecular mass of any elements. Just you can see here the 6 and 12, the carbon. 12 is the atomic mass, which is number of neutron plus number of protons. It means in the mass spectroscopy we will deal with the molecular weight, which is generally defined by the AMU, atomic mass unit. So it is the advantage of mass spectroscopy to get the molecular weight of any compound, which is very useful for the elucidation of any structure. The important thing is mass spectrometer, how it works and what are the components. First we will deal with the components. It has three major components. The first one is source, second one is analyzer, third one is detector. Source, which will provide the source of energy, and the second one, energy. If the molecule will get the energy, it will get ionized. It means the chemical ionization will happen in this source chamber, and then analysis happen in analyzer on the basis of stable ions. The analyzer will select the stable anions and it will proceed further to the detector, and detector will detect the molecular ion by Z by Z ratio, charge mass upon charge ratio. Charge is generally 1, so automatically it will detect the molecular weight of any elements. So these are three very important components of the mass spectroscopy. The important thing is how it works. These components, how it generated the ion and mass of any compound. Now you can see in the source portion the energy was provided to the molecules, and then the molecule gets ionized through the removal of electron from the molecules. It gets molecular ion peak over there. Now the ion is unstable in that case because it has energy, large amount of energy, so it will want to be stable ions, so it will fragmented in a different ion, and then among the stable ion which will go to the detector in the higher density, higher intensity. So in that case the stable ion will have a high intensity, which is generally known as a base peak. So this is all about the basic principle of the mass. After the component part, we will discuss about the source, analyzer and detector in briefly. The source is very important, where the energy source we will discuss about how the molecule gets energy. We have generally two types of sources, the chemical sources and the electron ionization source, where electron is directly bombarding to the molecules. That is ESI, electron spray ionization. But in case of chemical ionization, the chemical were used as a source of energy. The electron transfer the energy to the chemical and the chemical gets to the molecule. It is some softer techniques. The APCI and MALDI comes under this techniques, chemical ionization. APCI, atmospheric pressure chemical ionization, and MALDI is a metric associated ionization technique. Now the analyzer part. Analyzer means to analyze the molecular ion based on the stability. The stable part will go to the detector. So it is the whole sole purpose of that. If suppose the molecule gets ionized, it will get many fragments, so we want only wanted fragments. So the analyzer is important for the analysis of ions based on the stability. And the third one is a detector. The high intensity, high molecular charge compound will go to the detector and it will get a base peak. The base peak will have the high intensity in the mass spectrum, where the relative intensity is in left side and then straight in the molecular mass is there. So the highest intensity peak is the base peak, which is the stable ion peak. It can be molecular ion peak if the molecular ion is now the source part, where the direct bombardment of high electron is in the case of ESI, electron spray ionization. In that case the molecular ion is highly unstable because of that, so it gets fragmented in the different part. It is very good techniques to get the different fragments. Now we will see the chemical ionization technique, where direct electron bombarding is not in the way, while the medium, as you can see, the medium, if the medium is gas, that is APCI. If medium is matrix, that is which is in MALDI, that is the MALDI techniques, where the electron is giving energy to the medium and then it's giving energy to the molecules, and the molecule gets ionized, and the less fragmentation will be there because the energy provided by the gases will be less in that case, and then molecular ion peak will be stable. It means the molecular ion will remain stable, not in the fragment. This technique is useful for where we need a molecular ion peak, not a fragment. In the case of fragment, we required a ESI, electron spray ionization technique. Now the second important component is analyzer, where the analysis of ions will be there. We have two techniques, TOF, that is time of flight, and the quadrupole. In case of time of flight, the time of the ions, movement of ion from the ionic chamber to the detector will be increased, so the stable ion will reach there. In case of the quadrupole, we have a 4-pole instrument where the ionic equilibrium will be there, and then based on that, stable ion will be in the detection. In the analyzer part, if you will see the time of flight, which have the ionic equilibrium from the chamber side, yes, you can see the plus minus charges are there, then large ion will take time to reach the detector, and the smaller ion will take less time than the larger one. So in that case, the smaller and larger will identify in that TOF. Increasing the time will sure that the stable will reach in the detector chamber only. And in the case of quadrupole, the technique which is generally useful for the separation of stable cation or anion form. First step is to separate the positive and negative ions by different poles. After the separation of plus and minus, the radio frequency wave will be considered as a flow source, and then you can see the large particle will move this in a simpler zigzag form than the smaller one. So smaller one will reach later than the larger, though the separation of ions will be in this case. It means the all ions will strike in a different time. So the separate peaks will be in the spectra, mass spectra. The stable ion will have the high intensity peak, which is generally base peak. That can be the molecular ion peak, because if molecular ion itself is stable, then it will act as a base. Now coming to the detector part. Detector role of detector is to find out the charge upon mass ratio of any fragment. After the detect the molecular ions or ions, then it converts to the graph intensity versus M by Z, where we can see the clear molecular ion peak as well as base peak and the fragment piece. So now the fragmentation part is very important to identify which functional group is there, which ring is there by the fragmentation pattern. Three types of patterns generally we can see in the organic compounds. The first one is heterocyclic, then second one is homocyclic, and third one is McLaurey cleavage, that is McLaurey rearrangement. And in the first case, as name suggests, heterocyclic means heterocyclic fusion is taking place in that case, where the two electron is taking part in the bond breakage. As you can see, the bromine ion is breaking the bond by the moving of two electrons and getting the ions of the parent's peak. This is the heterocyclic cleavage. Now coming to the next fusion, homolytic fusion, where the homolytic fusion is taking place means the free radical cleavage, where the single electron is moving towards its own component. As you can see, after the bromide ion formation, the alpha bond is breaking in the homolytic fashion, where we can see the two fragments patterns are in the picture. So in this case, the two fragments will attach to the detector and they will give the complete fragments. And the next one is very important, McLaurey cleavage or rearrangement, where the keto group is present with the gamma hydrogen bearing carbon, and then gamma hydrogen is taking place in the very important role in the this McLaughlin rearrangement, where the alpha and beta is getting its own electron, and then beta bond is breaking in that case, and the fragments you can see the first fragment with hydrox group and second one is alkane group fragments. So this is very important fragment pattern where carbonyl and gamma hydrogen is present in that case. We discussed the basic components and the basic principle, as well as the fragmentation pattern, McLaughlin rearrangement, base peak, and other important things. Now many things are remaining for the concept of mass spectroscopy, so we will discuss in the next segment. So before that, it is enough to get the acquainted with the mass spectroscopy. Thank you, be happy and follow the positive arena. Thank you. Thanks.